Hi all, today we will discuss about an important concept called advantages of pipelining. So, all of you know about pipelining, right? Pipelining is a important technique for implementing parallel processing using uniprocessor system. That means we have a single processor and using this single processor we can achieve parallelism using a concept called pipelining. So, pipelining is basically a technique which allows you to execute multiple instructions in a less amount of time by a single processor. Then you might have wondered why it is named as multi-process pipelining. The name pipelining it comes because if we have multiple stages, if any task can be divided into multiple stages S1, S2, S3, S4, and these multiple stages takes the input and output of one multiple stage becomes the input for another multiple page another stage. So by this way what happens, these are the different stages. Any task can be divided into these number of stages in pipelining, and the reason why we call it as a pipelining means the output of stage 1 goes as a input for stage 2. Similarly, the output for stage 2 goes as a input for stage 3. Similarly, output for stage 3 goes as a input for stage 4. So what happens here, different stages, a typical execution task, let us say this is my execution. This task can be divided into different stages such as instruction fetch, instruction decode, calculate operand, fetch operand, execute, and write the result. So I can divide an instruction execution into these 6 stages: instruction fetch, instruction decode, calculate operand, fetch operand, execute instruction, and write the results back. 1, 2, 3, 4, 5, and 6. So by this way, an instruction execution cycle can be divided into these 6 stages, and each stage uh, the input the output of stage goes as a input for stage 2, and output of stage 2 goes as a input for stage 3, Similarly, the output of stage 3 goes as an input for stage 4, and the output of stage 4 goes as an input for stage 5. Similarly, the output of stage 5 goes as an input for stage C. So by this way, these all phases are interconnected. For that reason, we call it as one big pipe. So this is the reason why we call it as pipelining architecture. So when it comes to pipelining, this is the pipelining process, but of course there are some uh, very much advantages with the pipelining concept. That is, instruction throughput increases. The first advantage is that instruction throughput increases. Throughput in the sense number of instructions executed per certain unit of time. That time may be seconds or something else. So what happens when I say instructions execution cycle, number of instructions per unit of time? So this number of instructions executed is nothing but it is called throughput. So what happens with pipelining? The number of instructions uh, executed per unit amount of time will increase by implementing pipeline. How? Let's assume this is my instruction fetch, instruction decode. For simplicity, we will take execute and results back. So the first stage, instruction 1 is in the instruction fetch state, and the second state, second cycle, let's assume this is 1 2 3 4 cycles. In the second cycle, instruction decode, third cycle, instruction execution, fifth stage, instruction storing the results. So at the same time, instruction 2, when instruction 1 is in the decode state, instruction 2 is in the fetch state. Similarly, instruction 3 is in the fetch state, instruction 2 is in the decode state, instruction 1 is in the execution state. Finally, when instruction 4 is in the instruction fetch state and instruction sorry, instruction 3 is in decode status and instruction 2 is an execute state and instruction 1 is in store status. So what happens, this is called parallelism. So why this we are calling it as parallelism? In the sense, see this thing, when instruction 1 is getting stored, instruction 2 is getting executed, instruction 3 is getting decoded, instruction 4 is getting fetch. So after 4 seconds, one instruction execution completes. After 5 seconds, second instruction will complete. After 6th second, third instruction. After 7 second, fourth instruction. So what happens, for executing 4 instructions, I1, I2, I3, I4, each instruction, if let's take takes 4 nanoseconds. 4 into 7, 4 into 4, total 16 nanoseconds takes in sequential processing or non-pipelining processing. But what happens, the same thing, but if you implement pipelining, what happens, for executing I1, I2, I3 and I4, for 4 instructions it takes 7 nanoseconds. See, if you follow non-pipelining, for executing 4 instructions it takes 16 nanoseconds, but if you implement pipelining, for executing 4 instructions it takes 7 nanoseconds. See how much difference. If you take the average, 16 nanoseconds for executing 4 instruction means 4 nanoseconds is the average time executing one instruction. But if you implement parallelism, it takes 7 nanoseconds for executing 4 instruction, so it is like 1.7 nanoseconds, and this 1.7 average time will reduce further if you take more number of instructions. By this way, what happening, throughput is getting increased. This is meant by throughput, increasing throughput. So now second advantage with the pipelining is that increase in the number of pipeline stages increase the number of instructions executed simultaneously. See, number of instructions that can be executed simultaneously, that uh, the process of execution starts can be initiated with more number of stages. If you have more number of stages, say let's assume if my instruction stage, as I said, instruction fetch, instruction decode, calculate operand, and fetch operand, and calculate operand, fetch execute instruction, and finally write the result. So what happens, 1 2 3 4 5 6, so 1 2 3 4 5 6. So with 6 stages, what happens, 6 instructions can be executed simultaneously. So if I have more number of stages, more number of instructions can be executed. So this is meant by the second advantage. What it says is increase in the number of pipeline stages increases the number of instructions executed simultaneously. Next, faster ALU can be designed when pipelining is used. See, why I am saying faster CPU means, take the instruction execution stages, instruction fetch, instruction decode, execute and store. Instruction, each stage may not take same amount of time. There may be different amount of time, like if it takes 6 nanoseconds, if it takes 4 nanoseconds, In general, it takes 10 nanoseconds, and it takes for storing maybe 5 nanoseconds. So what happens with this is that the amount of time required for each stage may not be same. In that case, you need to employ a buffer in between the stages. Let's take this uh, instruction decode and execution of instruction. When it is completed in 4 nanoseconds, definitely you need a buffer, because meanwhile the previous instruction is still in the execution, because it may take 10 nanoseconds. So we need to reduce this amount of time, right? So we need, and execution is done by ALU. So what happens to have maximum uniform amount of time here? We need to design, we need to reduce this time to less than 10 nanoseconds. So then we should have a faster ALU. So the pipelining allows, gives a provision to design an ALU which is very faster ALU. Next, pipelined CPUs works at higher clock frequencies than the RAM. So pipelined CPU works at higher clock frequencies than RAM. That means if I have a processor with pipelining, its speed is very much high when you compare with RAM. So by this way, what happens, it allows you to it gives a provision to use cache memory. So this is one of the biggest advantage. And next point is that pipelining increases the overall performance of the CPU. Yes, it is true. But at the same time, there are some hazards which is very much necessary to discuss. As I said, if all the stages are doesn't take uniform amount of time, definitely you need to employ a buffer here. You need to place buffer over here. That is the first um, hazard. And then there is a data hazard. Let's assume one instruction here is executing at execute state, another execution is in decode state. They may both want to access the same data resource. It is called data hazard. So with data hazard, what happens when the previous instruction wants to access some data which is not available, then that instruction is in pending, especially for IO operation. And if the next instruction is also waiting for an IO operation, then what happens? This pipeline cannot move. Next, resource hazard. Resource hazard means if the both are looking for the same resource, if two consecutive instructions are looking for the same resource, then it is difficult to handle the situation, which is called resource hazard. Then there is a consistency hazard or data hazard, which says that when the first instruction is trying to update the data, still its execution is not completed. Meanwhile, the second instruction you might want to read the data, which leads to data inconsistency. So these are some of the disadvantages of the pipelining as well. So it is very important to understand this concept. There are it is equal to know that there are certain limitations with the uh, pipelining process as well. So these, although there are limitations, but there are very much advantage process. Next, I have parallel processing. The parallel processing, now we see some advantages of the parallel processing. Before looking at the advantages, let us try to understand what is this, what is the importance of parallel processing. So the parallel processing means, here what happens, uh, parallel processing means what happens, so the parallel processing means having multiple processors, multiple processors. So the multiple processors can be achieved by having, so the parallelism can be achieved by two ways: by having multiple processors in single computer, or by having group of computers. Both are possible. So the parallelism basically means, one way of implementing parallelism means a single computer, if this is my CPU, the CPU will have multiple, having multiple processors. By having multiple processors, one possibility. And second possibility is that parallelism can be achieved having group of computers that are connected together. If computer 1, computer 2, computer 3, here group of computers are connected together. By this way, we can achieve parallelism. But of course, this is called grid computing or cloud computing, which is beyond the scope of our syllabus. But the parallelism can also be implemented, as I said, single computer having multiple processors. This is most important. How it can be means, there is two types. One is, because before understanding the advantages of parallel processing, it is really important to recap what is meant by parallel processing or parallel computing, how it is implemented. Then this multiprocessor in a single computer can be divided into tightly coupled processor or loosely coupled processor. So it can be tightly coupled processor or loosely coupled processor, loosely coupled multiprocessor or tightly coupled multiprocessor. So in case of tightly coupled multiprocessor, what happens? All processor, let me draw the block diagram of tightly coupled multiprocessor because it is very important. Tightly coupled multiprocessor, we can call it as a symmetric multiprocessor. And how it works means there are number of processing elements or multiple processors, processor 1, processor 2, processor 3, processor 4, and next a strong inter-network connection which will connect to memory and connected to I/O devices. So this is called tightly coupled multiprocessor. So why it is called tightly coupled multiprocessor means here see the processors are connected via an inter-network connection. They can communicate one another using this network. Similarly, this network, backbone network, is used to connect processor to a shared memory, processor to an I/O device. So they are all strongly connected, symmetric. Each processor gets equal right, has the equal chance of communicating with the shared memory or I/O interfaces. All processors are treated as a equal. For that reason, we are calling it as symmetric multiprocessor. This is also called SMP, that is symmetric multiprocessor, which is called symmetric multiprocessor. This is called symmetric multiprocessor. So with the symmetric multiprocessor, what happens? Each processor gets the equal right to interact with uh, the remaining processors. Similarly, each processor has the equal right to communicate with I/O devices, and each processor has the equal right to access shared memory. It is really understand. It's really necessary to understand this symmetric multiprocessor system before understanding parallel processing. So parallel processing means it can be implemented within a single computer having multiple processors, or it can be implemented, the parallel processing can be also be implemented by using a group of computers that are connected together by using which is called grid computing or cloud computing, or even it is called Internet of Things, IoT, which is an advanced topic and beyond the scope of this syllabus. So when it comes to symmetric multiprocessor, that is single computer equipped with multiple processors like the black diagram shown the screen, multiple processors are connected together by using an interconnection network, and this interconnection network also allows all these processors to communicate with memory and I/O interfaces. I/O and I/O interfaces and memory. I/O interfaces and memory. So by this way, what happens? So now Parallelism means when you read or understand parallelism, it can be, you should know that it can be symmetric multiprocessor, tightly coupled, or loosely coupled. Loosely coupled means there is each processor cannot have a equal right. One processor, yeah, it's very important to understand what is meant by uh, loosely coupled, loosely coupled multiprocessor. So when I say loosely coupled multiprocessor, that means all processors don't have the equal rights to access the shared resources like memory or IO interfaces. One processor acts as a master processor. One processor acts as a master processor and the other processor acts as a slave processor. So one processor acts as a uh, master processor, another processor acts as a slave processor. If the slave processor wants to access some memory shared resource like memory, but it has to request master processor. So the master processor may receive the multiple requests to access the memory, then it has to grant according to some priorities or privileges. So here processors are not at peer processors. They don't have an equal right to access some shared resource. Based on the priority, one may get choice. This is called loosely coupled multiprocessors. So it's really important to understand this tightly coupled and loosely coupled multiprocessor when it comes to implementing parallelism within a single computer. Now we look at some of the advantages. So before going to advantages, let us try to understand what is the importance of parallel processing. The goal is to faster execution. Of course, the goal of the pipelining or parallel computing both are executing instructions at fast. So the parallel computing saves the time, allows the it saves the time, allows the execution of application in shorter wall clock time. Of course, there are multiple processors working. Each processor can be assigned with some instructions. By this way, execution of an application becomes shorter execution time. Solves larger problems in a short point of time. It is a very important point. When you have given complex problems, you can divide that complex problem into some smaller problems and assign each of them to one processor. So, by implementing parallelism, complex problems can also be solved. Compared to serial computing, parallel computing is much better suited for modeling, simulation, and understanding complex real world phenomena. So, it's very important to understand. Let us take the neurons in the brain of a computer. So, if you want to know how the neurons behave in a computer, it is called simulation. This is called simulation. First, you have to model these neurons. First, it is required to model the neurons, and second one, do simulation, and third one, we can understand complex real world phenomena. So it is quite possible to understand complex real world phenomena. When it comes to modeling the neurons, when it comes to modeling the neurons, simulation, understanding. First, you have to model the neurons, you have to simulate the neurons, you have to understand. For this process, we can use parallel processing. So, it solves larger problem in short amount of time. Especially this parallel processing is used to compute the complex problems, and it's suited for modeling, simulation, understanding complex real world phenomena. Next, throwing more resources at a task will shorten its time to completion. Yes, because we have separate processor available. Of course, there is a shared memory, and each processor can access the shared memory. Because we are having more than one processor, throwing more resources at a task for completing a task will shorten its time to completion with potential cost saving. It also leads to cost saving in terms of time complexity, in terms of short execution time. Parallel computers can be built from cheap commodity components. So, these parallel computers, that is symmetric multiprocessors, can be built from cheap and commodity components. It doesn't it also not so costly. See, even if you take a mobile phone of 8,000 cost, you might have here, if you see, if you read the configuration, dual core, quad core, octa core processor. This is the configuration that you might have seen when you purchase a mobile. Dual core means here processor is divided into two units, P1 and P2. Quad core, here processor is divided into four. That means there are four processing elements. Similarly, octa-core means 8 processing elements. So there are 8 processing elements. So what happens with this? They are cheap. When you in the 8,000 cost mobile itself having octa-core processor means you can understand how cheap it is employing this multiple processors, and it is how cheap it is implementing parallel computing. Next, many people or many problems are so large and are complex that it is impractical. So many problems are so large and complex that it is impractical or impossible to solve them on a single computer, especially given limited computer memory. So some complex problems like simulation, as I said, modeling, simulation, some problems like modeling, simulation, and understanding, all these things are complex problems, and these complex problems cannot be achieved by using single computer. It is impossible. So many problems in real world, what happens, it is not possible to solve those problems in a single computer, especially with given limited computer memory. So you can do many things simultaneously by using multiple computing resources. So you can do many things simultaneously by using multiple computer resource. Because we have multiple computer resources, processors, there are multiple processors, Even you can deploy each local memory. Yeah, it is very important to understand how loosely coupled multiprocessor works. Each processing element will have a separate local memory. For processor 1, local memory 1; for processor 2, local memory 2; for processor 3, local memory 3. So with this, what happens, each processor has its own local memory, due to which uh, there are number of more number of resources are available. So you can do many things simultaneously by using multiple computing resources. Multiple computing resources means having multiple processors and multiple memories. Multiple memories and multiple processors. So can using computer resources on the wide area network or even on the internet. I tell you, the parallel computing can also be achieved by using a network of computers. Yeah, the better word, rather than group of computers, we can call it as network of computers. So what happens with this network of computers? Network of computers are connected together to form a LAN, local area network, MAN, metropolitan area network, or even WAN, wide area network, which is called internet. So various computers located at various geographical location, they can be connected together and they can achieve parallelism, which is, this is nothing but which is the trending topic that is called IoT. IoT stands for Internet of Things. So it can help keep you organized. If you have internet, then communication and social networking can be made easier. So all these things are because of parallel processing, and it has massive data storage and quick data computations. Because of this parallel processing, what happens, there are some computers which are located geographically at different area, but one of the computer can be maintained as a data server. And with this data server, what happens, you can connect this data server by using internet. By using internet, various computers located at different geographical area can be connected one another and to this data server. Now we see the parallel processing is really simultaneous data processing task for the purpose of increasing computational speed. If you take the processor registers, by having separate functional units, we can perform all the tasks in parallel. So the simultaneous data processing task for the purpose of increasing computational speed, here what's happening, if this is my processor register, these are the processor registers, and this is connected to memory, this is in fact processor, and this processor has been divided into different processing elements such as adder, subtractor, which is exclusively performs addition and subtraction, Integer multiply performs fixed point multiplication. Logic unit is used to perform execute if conditions, comparisons, any boolean logic. And shift unit, which is used to perform right shift and left shift. Incrementer unit, so this incrementer can be used for incrementing and decrementing, and especially for doing floating point arithmetic it is very important. See, the computation speed of a processor can be measured with how effectively it can compute floating point operations. That means uh, floating point addition, subtraction, floating point multiplication, floating point division. As you know, floating point uh, addition and subtraction, or floating point multiplication or floating point division is a complex task which takes considerable amount of time. So if you say, if some company designs a processor, says that my processor is very much fast than any state of the art processor, the only test it has to go through is the how effectively it can perform floating point arithmetic, that is floating point addition, floating point subtraction, and floating point multiplication and division. So perform concurrent data processing to achieve faster execution. So we have to employ multiple functional units like this.